Today we're going to talk about volume of a cylinder, but before we discuss cylinders, we're going to talk a little bit about a circle. Now, in order to find the area of a circle, we use pi r squared. The area of a circle is pi r squared. Now, the difference between a circle and a cylinder is that we add another dimension. You can see I have a bunch of circles here in my hand. I'm going to take these circles and I'm going to stack them on top of one another. So now instead of having a circle, I have a three-dimensional shape that now has a height. In order to find the volume of a cylinder, we're going to take the area of the base, which you can see is a circle, and multiply it by the height. So in order to do that, we have to know how to find the area of a circle. Area of a circle is pi r squared. If the area of a circle is pi r squared, then in order to find the volume of this three-dimensional shape that you can see, I have that area a certain number of times, which is going to be the height. So volume of a cylinder is pi r squared times height, where this pi r squared represents the area of the base times the height. I've sketched a little cylinder here. You can go ahead and sketch that. It has a base and it has a height, and I just indicated that the base of this object is going to be a circle, and height is this distance from the bottom base to the top base. So volume of a cylinder is area of the base times height. Area of the base is indicated by this capital B. And area of the base for this particular object, which is a circle, is pi r squared. So what we really want to take away from this is that volume of a cylinder is pi r squared times height. You can see that's the area of the base, and that's the height. Let's try to use this formula. Go ahead and sketch our first example. We have a cylinder, and your sketch doesn't have to be perfect. You can see mine is not. It has circular base, and it has a height. The height of this cylinder is 6 meters, and the radius of this cylinder is 3 meters. Remember, radius is halfway across the circle, and the diameter is all the way. When we're using this formula, we need the radius. We need halfway across the circle, which in this case is 3 meters. The first thing we're always going to do is write down the formula. So volume of a cylinder is pi r squared times height. You can see we have the area of the base times height. And then we're going to plug in what we know. I don't know my volume. I'm going to leave pi right now as a symbol and not put the decimals in. My radius is 3, so I'm going to plug in 3 where I see my radius, squared, and 6 is my height. The volume is pi times 3 squared times height. Now I want to do a little simplifying. 3 squared, we should all know this off the top of our head now, is 9. So when I simplify that, I have pi times 9 times 6. I could actually simplify this a little bit further. Remember, it doesn't matter the order in which we multiply things. I can do pi times 9 and then multiply that product by 6, or I can do 9 times 6 and take that product times 5. I'm always going to multiply my whole numbers together first, So 9 times 6 is 54. So I have 54 times pi. And if I plug in 3.14 for pi, 54 times 3.14 is approximately 169.6 meters. Now remember, because we're talking about volume, we are always going to have units cubed. In area talks about a two-dimensional object and how many square units it would take to cover that object. In this case, 8, we'll call these meters too. Units squared, because these are 2 by 2, 1 by 1 squares, meters squared. It takes 8 of those squares to fill this object. Volume, we're talking about how many units cubes, whatever the unit might be, we can put inside of an object. So how many of these cubes would it take to fill this cylinder? It would take 169.6 of those cubic meters. That's why our volume is going to be cubed. This time, let's use the formula to help us find the height of an object. This time, I'm going to draw a cylinder that has a volume of 314 cubic inches, and it has this dimension here that's being given to me. I'll give you a second to go ahead and draw that. Now, because this dimension is shown going the entire distance across the circle, this dimension that's being given to us is the diameter. If you look back to our formula, volume is pi r squared times height. There's no diameter being used in this formula. But I know that the radius is half of a diameter. We'll call this 10 inches. I know that the radius is half of the diameter. So in this situation, half of 10 is going to be 5. So my radius is 5 inches because it's halfway across the distance of this circle. So I'm going to start again by writing down my formula and plugging in what I know. This time, I know that my volume is 314 inches cubed. I'm not putting my units into my formula because I might be tempted to cube something when I'm not supposed to. I'll just add the units back onto the label at the end. I have pi r squared and height. I do know more information though. I do know my radius and my height, so I'm going, not my height. I know my radius, so I'm going to fill that in. 314 is pi times 5 squared times h. A little bit more simplifying I can do. 314. It looks like I have pi times 5 squared. I know what 5 squared is. 5 squared is 25 times height. My goal here is going to get this h by itself. H I can see is being multiplied by 25 and multiplied by 5. The opposite of multiplying by 25 and pi is to divide by 25 times pi. I need to know what this is before I can divide by that number. 25 times 3.14, I'm going to put that into my calculator, and I get 78.5. Times my height. H is being multiplied by 78.5. The opposite of multiplying by 78.5 is to divide both sides by 78.5. And I'm left with H equals 4. So the height of this cylinder is 4. But we can't forget, 4 needs to have a label, 4 inches. I know it's inches because my diameter was in inches and my volume was in inches cubed. So that means that my height is also going to be in inches, 4 inches. The last example we're going to do is we're going to use this information that's given here. I can see I have a cylinder that has a height of 4 centimeters and a volume of 452.16 centimeters cubed, or cubic centimeters. I'm going to start this problem exactly the same way I start the others, by writing down the formula for the volume of a cylinder. Volume is pi r squared times height. Remember, we get this pi r squared because it represents how we find the area of the base, which is a circle. Pi r squared times height. I'm going to begin by filling in the information that I know. I do know my volume, 452.16. Again, I'm going to leave off the label. I can see that I'm dealing with centimeters and cubic centimeters, so I can just add that back in later. Pi is 3.14 times my radius squared. In this example, I'm not given my radius, so I'm just going to call it r, times my height. And the height in this example is 4 centimeters. There's nothing I can do on the left-hand side of this equation. I'm going to bring it down. 3.14 times r squared times 4. It doesn't matter the order that I multiply these items. I'm going to start by multiplying the numbers that I know first. So 3.14 times 4. Which is 12.56. Now I've combined these two like terms. Now I can't not forget about my r squared here, times r squared. My goal is to get r by itself, this unknown variable. R is being multiplied by itself and multiplied by 12.56. I'm going to undo this multiplying by 12.56. Opposite of multiplying is dividing. $452.16 divided by 12.56 is 36. And what's left on this side of the equation is r squared. The opposite of squaring a number is taking the square root of it. So I take the square root of both sides. The square root of 36 is 6. So the radius is 6. 6 what? Well, my height was in centimeters and my volume was in centimeters cubed. So that means that my radius is also going to be 6 centimeters.